main central area of the app. And most of the business logic layer classes are going to end up calling data access layer or common assembly classes. And the data access layer or some kind of service layer is going to talk to the database or talk to services. If the dependency flows in this direction, and since we know dependency is transitive, this means that the user interface is always dependent on the business layer, and the business layer is always dependent on this data access layer, which in turn depends on the existence of a database and services in order for it to function. What this means is that your application is very difficult to test or change or work with in isolation from a database or these services because of this hard dependency that's flowing from the business layer through the data access layer. This means also that we are not depending on an abstraction. Rather, we are depending on an explicit instance of the data access layer, which we're going to be working with. We can invert this architecture so that the thing that sits at the bottom of our dependency structure is instead the object model, the core, the domain object, as well as perhaps our business logic and services. These can be packaged together as a single assembly, or separately if you prefer. It's also important to note that any of the dependencies that these have are represented by interfaces at this layer. Next, the other areas of the application, such as data access, user interface, tests, I/O operations, and web services, or WCF, would all be on top of this and would depend on these services and objects. Infrastructure concerns outside of our application, such as the database or web services themselves, would reside off to the side, where only the data access module would depend on it, or the WCF or web service module. But note that our business logic and core domain objects do not have this dependency, and as a result, they can be tested without having to have these in play. Let's look at a demo of how we can build an application that follows the traditional hierarchy and what effect this has on our ability to work with that application. One of the new features of Visual Studio 2010 is the ability to use the Architecture tab to generate a dependency graph by assembly. If we do this first project, we'll see something like what's shown here, where we have our ntier.web and web service assemblies at the top of our dependency hierarchy. And these are correspondingly referencing our business logic layer. And the business logic layer is currently referencing the data access layer. The data access layer, as well as pretty much every other assembly, is making use of a set of common functions that's in a common assembly. And then these are all referencing externals, such as video.net or web service classes. This is also where you would find things like the database or external things like the file system, etc. Looking at this design, it's very clear that our business layer depends on the data access layer, which in turn depends on externals. This can make it very difficult to change the business layer or to test it in an isolated fashion. For instance, if we were to go and create a test class like this one, we could say that we wanted to have a class that tests the security class of the business layer, and say that security's login method should return a user ID for a valid user. We construct our test with a valid user ID, email, and password, and of course we would like to be able to inject these into the system somehow so that we could do this test with our data here that we are passing in. Unfortunately, this is implemented as a static method, making it very difficult for us to do any sort of dependency injection. And when we write this test, if we stop ignoring it and run our test, we'll see that because of this dependency on the data layer, our test throws an exception, and that exception is that it can't find the connection string in the web config. Of course, I don't want there to be a connection string in my unit test web config because I don't want unit tests to be talking to external resources. I only want to be testing the business layer. I don't want to be testing the data access layer or the database with this particular test suite. Now, I actually put together this demo many years ago when .NET 1.0 was out in order to show how Untier applications should be structured. This is before I was familiar with the dependency inversion principle. And one of the things that I struggled with as I put together this demo was how I could easily swap out one data access layer for another. Part of the intent of this demo was to be able to show how easy it would be to take, for instance, our security layer and change it so that the data access layer that it's using could be swapped from one that uses SQL Server through the SQL parameters and SQL connections for a different data access layer, which is here called data access layer 2. And data access layer 2 uses an XML file. So the idea was that one could switch from one to the other. And in the course of my demo, the way that I would do that, because I didn't know any better, was that I would go in here and I would have to change DAL to DAL2, and I would have to change my references to make sure I had reference to data access layer 2. And everywhere that I called data access layer 1, I would have to change those references. Of course, if I can just delete the reference and lean on the compiler bit, it'll show me all those places, and I can come in here and change them appropriately. In this particular demo, I only have 3 methods that call data access layer, so I only have 3 places where I need to make this change. But the fact that I have to go and touch every line of code is definitely a violation of the open closed principle, and it was certainly something that bothered me at the time, but I just didn't know of a proper way to change that and avoid that situation. Many applications that I still see have the same problem because they rely on static methods and or because they use the same type of dependency hierarchy that puts the data access layer below the business layer with a direct class level reference and assembly level reference that passes from the business logic to the data access logic. This results in more fragile applications that are more difficult to change as you evolve them and as you wish to adjust their behavior. Let's analyze some of the problems with the existing application structure. The biggest one is that dependencies tend to flow toward infrastructure concerns such as the database and XML files going through data access layers that are tightly coupled to these structures. The core business layer and domain classes, such as we have them in this example, all depend on these implementation details. And if these implementation details change, it requires us to go in and change our business layer, at the very least recompiling it, but in this case actually going and touching lots of individual method calls in order to fix their references so that they continue to function. The result of this is that we have tight coupling between the business layer and, by extension, the data access layer and the XML file and the infrastructure components that we are using in our application. There's no way to change the implementation details without a recompile, resulting in an open-closed principle violation, and making it very difficult to test in any kind of an isolated fashion. Dependency injection shows that dependency is transitive. If the UI depends on the business logic layer, which in turn depends on the data access layer, which in turn depends on the database, then everything depends on the database. We want to instead depend on abstractions where we know that there are likely to be changes in our application. We want to package up these abstractions, these interfaces, with the client that's using them, in this case the business logic layer, in keeping with the interface segregation principle. Finally, we want to structure our solutions and projects so that the core or business logic layer is at the center or at the bottom of our dependency hierarchy, with the fewest dependencies and with no dependencies on external infrastructure. Now let's see a demo of how we can refactor our naive n-tier design into something that follows the dependency inversion principle and gains some of the benefits of a more flexible architecture. We're going to refactor this n-tier application in order to make it work in such a way that the business layer is the center of all the dependencies, rather than depending upon the data access layer. I've changed the application back to where it was when we started so that it's now using the n-tier data access layer assembly, which is depending on the SQL database. If we run our test here, we can see that it fails, and it fails with the exception saying that it cannot find our connection string. The reason for that is because this security.login method is defined over here, and it's calling data access layer security login through a static method call. And if we look at the data access layer security login, we can see that it's actually generating some SQL, opening up a connection, and ultimately executing that using ADO.NET. When we're done, we'll be able to use this test with a little bit of additional code in order to pass in the expected record that we want to find, run our login, and verify that it did in fact return the correct result. We'll then be able to add additional tests if we like to make it so that our login and security classes function the way we expect them to. Let's get started. The first thing we need to do is go into the security.login method and make it so that it's no longer static. Static methods are very difficult to test and very difficult to mock out in your test, so eliminating that is the first step in improving our design. Once we do this, we need to build and fix anything that was expecting a static method and change it by simply newing up the class that we need and applying a couple of parentheses. If we do this in each location where it is being used, we quickly get back to a state where everything builds. There. Now we have a security class instance that we can use. The next step is we want to generate an interface that shows the things that this depends upon. I'm going to use what's called the repository pattern in the definition of my interface to make this work. Now, if we look at what the security code is actually doing, it's selecting a user based on their email and password and returning back that user record. So let's look at how we would identify an interface for this. In the security class, at the business logic layer level, we would say that this is depending on some kind of a data access repository that's able to get a user by email and password. So I'm going to say that we need a new interface. We'll call this public interface user repository. And we'll say that it has a method called get by email password that takes in a string email and a string password. And it returns back an int, which is the user ID. Now I can also come in here and say that I need a new constructor for security. And in this constructor, I'm expecting, we'll make this an iUser repository. I'm expecting an iUser repository called user repository. And I'm going to introduce and initialize a field called underscore user repository. And I can take that instance and use its method here. So I really want to say underscore user repository dot get by email password. And at this point I'm back to a state where I can rebuild. Except that I don't have a default constructor. So the next thing I need to do is create a default constructor. And I'm going to have it use the other constructor's interface and pass in a default implementation, which in this case we're going to say is a SQL user repository. I don't actually have one of these yet, so we're going to generate one. And this all looks good. And we're going to implement the members. And now we should be able to build. Alright, maybe not. What did we miss? Oh yes, we need some curly braces. And now we can build. Alright, so at this point we have an interface. We have a couple of constructors now.